Okay, today we're going to be doing lesson 8.2, linear equations in two variables. We're going to be doing 8.2 in two parts. We're only going to do half the notes today, and then we're going to do half of the notes later on. In today's part of the notes, we are only going to learn solution of equations in two variables. So we're going to be learning how to do this vocab right here. And then we are going to learn how to graph an equation with two variables. But the only ones we're going to graph today, learn how to graph, is if it's already in function form. So everything that you'll get today will already be y equals and then an equation behind it. It'll already be in function form for you today when we learn how to do t-charts and graph them. And like we were talking earlier, if your graphs, after you do a t-chart and then you put them on the graph, they don't make a straight line, you did something wrong. Okay, so you'll know, you don't even have to look in the answer book. If you don't get a straight line on your graph, oops, back to the drawing board. Either you graphed something wrong or you did something wrong in the t-chart. Okay? Okay, example number 1. Now this is checking solutions. These you need to show your work on your worksheet, or today it's a book assignment. So for example, if this was number 1, and they give us this equation, x minus 3y equals 8. They want to know, is this ordered pair a solution to this equation? This is the same equation, they just rewrote it down here. Does that ordered pair work? Well, now here's an equation with two variables. So how do I know? The first thing, and remember I told you this earlier this year when we were working with equations, what's the first thing you probably should always do when we're dealing with, anytime we see negative numbers? Now it's more so if the negative were like in front of this, if it was a negative x. What's really important to know? What do we put around it? Parentheses, yes. Because just sometimes that'll make a difference between your positive and negative answers to throw you off, especially when you're doing your t-charts, all right? So, out of this ordered pair, which one is my x? Yay! 5. Alphabetical order, x and y. So we put 5 in for the x, put -1 in for my y. Okay, so let's substitute those underneath so I can see all your, write it neatly in your homework. So I know what you're doing. So we have 5, that goes in here for my x, minus 3 times what? A -1. Now you got the question mark here. Does that equal 8? Yes or no? Well, what do I do first? Multiply what? Excellent. Okay, what do I get when I take a -3 times a -1? Positive or negative? I get a positive 3. Bring down my 5. Does 5 plus 3 equal 8? 8 equals 8. So is that a solution to that equation with two variables? Yes. That one works. That is a solution to that equation. Practice these. Here's my x, here's my y. Rewrite your equation. So I have 2x. Now here's where I'm talking about those parentheses coming in handy. 2x minus y equals 5. Does this side of the equation equal this side of the equation if I substitute in these numbers? Well, I'm going to have 2 times what? 0. Yep, 2 times 0 minus, and what is my y? Careful, -5 equals 5. Now this is where I can't emphasize this enough to be super careful on these so you don't goof up on your t-charts. Because if you don't know that this is a double negative, you'll end up getting negative numbers instead of positives. And then when you plot them on your graph, you're not going to have a straight line. Or, okay, you'll be like, I don't know what's up. It's right here. This is where you need to be super careful. So 2 times 0 is? Excellent. And a negative, there's that assumed 1. A negative 1 times a negative 5 is? A negative 6, right? Oh, you are awake. Good. No, it is not a negative 6. It is a positive 5. Excellent. So 0 and 5 is 5. Does 5 equal 5? Does that one work? Yay. That one gets the smiley face. Indeed, it works. Okay, do number 2. Same equation. Raise your hand when you get this one done. What do I substitute in here, Alex? 3? What do I put in here? Yep. Okay. Everybody had the right number substituted in? Raise your hand if you say yes, this works. Raise your hand if you say yes, this works. Oh, you still are awake. No, who says no? Excellent. So you must be getting something other. 2 times 3 is what? A negative 1 times a 2 is? A minus 2. What is 6 minus 2? Does 4 equal 5? Wah, wah. Nope, that one does not work. That one is not a solution. That, if I put that point, if I go over to the 3 and up to the 2, that would not be on that line, that equation. That dot would be off the line. Nope, not going to work. All right, do number 3. Two times what, class? What did you substitute in here? A negative 2. And that leaves the negative 9 here. Who says yes? Who says no? Ooh, we got some of each this time. Good. That always makes it interesting. Debates. Here we go. So 2 times a negative 2 is? A negative 4. A negative, assume 1. A negative times a negative is a, so that turns into a plus 9. Does that equal 5? Fight or no fight? A negative 4 and a positive 9. Fight, who wins? Positive, so we have a positive what? 5. Does that equal a positive 5? Yes. That one is a solution, so that set works. Question?
So if the equation was 2x minus y equals 5, because the answer was a negative 5, would that not work?
Excellent question. So if I got down to this point and this would be a negative 5, and that equals 5, what would I have to put? Would that ordered pair, would that point be on the line? They're both 5s, but one's a negative, one's a positive. Does that work? No. Excellent question. No, that would not work. They both have to be negatives or both have to be positives. They have to be exactly the same. Okay, so that's the first part of your assignment today. Now, the fun part. We're going to learn how to plot our equations and make a line, linear equations, on our graphs. Now, in your notes, and a lot of times you'll see this in tests or quizzes or something, or like your map tests or ND, your North Dakota test. You'll see them in a horizontal chart like this, a table, with your X's and your Y's. It'll say, make a table of your solutions, then list your solutions, graph them. Okay? Graph them to see. Where'd that button come from? Graph them to see if they are ending up in a line. Now, what I want you to do, though, to learn how to do them, I'm going to turn that off because it'll start ringing again, I suppose. We'll see. I don't know how to run that thing very well. Hopefully it works. All right. So what I'd like you to do is T-chart. Obviously, for obvious reasons, it's a T-chart. See here? The letter T. We make a T-chart. You put your X's on this side, your Y's on this side, because that's how they are in an ordered pair, your X and your Y. Now they tell us, they give us our X's here. So write those over here. -2, -1, 0, 1, and 2. They're telling us to use those. Now, if they give me those points, what do I have to do to find the other point on the graph to make it work with this equation? And like I said today, all your equations that you do T-charts for, they're already arranged, so it's just y all by itself over here on the left side of the equation. We don't have to do any rearranging. We're going to learn that on the second part. But for today, we're just going to learn how to graph them when it's already in what kind of form? If it's y equal? Was that last vocab? What was it? This is in what kind of form? Function form. Thank you. You are right on for a Monday morning. Okay, so this is in function form. Let's figure out if my x, if this x is a -2, okay? What will my y equal if I put a -2 in for this x? And now on your homework, you're going to have to show your work off to the side because you'll come up to me, or students will come up and they'll say, Mrs. Lennon, I can't get this one to work. It's not on the graph. It's not on the line. And I'll have to go back and look at your work. But if you'll say, well, I did it on the calculator, I did it in my head, I can't help you because I don't know where you're going wrong. So you need to rewrite them off to the side of your paper. So your work here for this one, you would write, so y equals a negative, and they want us to put the -2 in here for the first one, -2 plus 1. What do I get for an answer here? Well, -2, or negative times the -2 is? Positive 2 plus 1? 3. So y equals 3. So over here, we put a 3. Okay, so if our x is a -2, our y has to be a positive 3 to work in this equation. Well, you can't make a line with one ordered pair, one dot. You don't have a line, you have a dot. So we have to do some more. They give us -1. So go over here and put a -1 in here. So a -1 plus 1, what do I get there? I get a positive 1, right? Plus 1, what does that equal? I end up getting 2. So where do I put the 2 now? Yep, behind the -1, because that's what we just put into that same equation. So now I put a 2. So see how these are my ordered pairs now? Now we're getting more of a line. Now we have 2 points to connect on our graph anyway. So now let's do another one with 0. What if I put 0 in for this? Y equals a -0 plus 1. What do I get? Okay, that's 0. Y equals 0 plus 1. So what does y equal? 1. Now we have 3 points. Now we're getting to the point where we can see a line anyway. Now when I have you do your T-charts, you have to do 4 numbers for me. You have to do a minimum of 4. Here they do 5. I tell you, you have to do 4. And you always have to have at least one negative number when you do your T-charts for me. And now look at, they use the numbers -2, -1, 0, 1, 2, which are really good to use for your x's because then you're staying close to the origin. Just think, if I used a -10 over here, well, are you going to start getting off of your chart then? -10, what would you get over here if it was a -10? A -10, you get 10 plus 1, it's going to be 11. So you're going to be getting way off your chart, way off your coordinate plane. So you want to use smaller numbers over here for the x's when you pick your own numbers. You can pick any numbers you want. I could pick 1/2 in here. I could pick 5 and get a number on the line. All right? You can pick any numbers you want to. Like you might pick 4 numbers. You'll pick another 4 numbers. They might not even be the same numbers. You might have 2 the same, but you might have 2 different numbers. Doesn't matter. You're both going to end up with the exact same line on the graph. Your points will just be in different spots on the line. All right, so what do I get here for 1? 1 and 0. Okay, and here I would end up getting 2 and -1. All right, so now we have our ordered pairs. I'm going to move this graph off over here so we can graph it now. Okay. Now we have our ordered pairs. Let's graph them. You guys have your graph on your sheet? Looks like some of you are already ahead of me. Good job, you got them on there. Now let's graph the first one, -2, -3. Or excuse me, +3. Here we go. -1, 2. 0, 1. 1 and 0. What's wrong? How come our points aren't going on a line? I got the same numbers as you guys did. How come yours is making a straight line and mine isn't? What happened? Right. So now if you ever have this happen to you, you get to a thing and you're like, oh, okay, something's not right. These 3 are on the line. This one's not. Well, then you got to go back over and see, did I graph it wrong? Or did I do some math wrong that this point is not on my line? Does that make sense? Now in this case, I'd go, wait a minute. Oh, whew, I just graphed that wrong. So then you got to fix it. So then I go 0, 1. Oh, 0, 1's right here, not over there. Then I go 1 and 0. That's better. And then 2, -1. That looks awesome. And then you use a straight edge. Use the side of your paper, a ruler, something, a tablet, and use a straight edge to make these lines. Don't freehand them, please. And you get your... Now that's on your paper, so you have this work on in your notebook. And then I'll give you graph paper to put these on. And then on your graph paper, obviously you have to number this. This is problem number 1. And what you do is you just put the equation that you graphed. What did I graph? This is y equals -x plus 1. That's the equation we just graphed. Make sense? Questions? So you'll have the T-chart and your work for each problem in your notebook. And then you'll graph it on the graph paper I give you. And we'll go from there, okay? So that's all we're going to go over today. Actually, I forget, because these are super easy, I forget we're going over these today. What if, say, problem number 2 says y equals 2? And you're like, okay, we're doing T-charts. I'm going to do a T-chart, x, y equals -2. Mrs. Lennon, what numbers do I pick? I always use 0, 1, -1, and 2. Where do there's no x to put anything in here. Whoa. Is there any work in your notebook when you get a problem that just is y equals -2? Is there 2 variables in that equation? No, so we can't do a T-chart if there's not 2 variables. This is so simple. Y equals a -2. On your y-axis, stop at the what? -2 and put a big old dot. Now, am I going to run my line up the y-axis? Obviously not. Why do I want to trace the y-axis? Y equals -2. There is your line. No T-chart needed, no nothing. Because there's not two variables. You have to have two variables to do a t-chart. So here, ooh, you have to do a t-chart, x equals 3. No, there's only one variable. So on the x-axis, find the 3, put a big old dot, and does that line go horizontal or vertically? If I go horizontally, I'm going to be tracing the x-axis. Do I want to do that? So that one's going to cut it vertically. Now we stop. That's what we have for today.